All right, we've got actually a good bit to cover in 2.5 still. Two other things that I want to make sure to bring to your attention. The first one is our last quiz of the unit is this Wednesday. The last quiz of the unit is this Wednesday. That'll be over 2.4 and 2.5. So we finished up 2.4 last week. We're going to finish up 2.5, if not today, then tomorrow. And then your test is next Friday. Test is next Friday. Yes, sir.
So the test will be over 1.1 and 2.5?
The test will be everything from 1.1 to, it'll actually go through 2.7. So we'll cover some material after the last quiz, but I don't want to give you guys a quiz and a test in the same week. So we'll quiz every couple of sections just to check in, see how we're doing, but as we get to the end, the last two sections probably not going to have a quiz over just that since it'll be on the test. Sound good? Okay. Let's start looking at these. Solving equations with rational exponents. There's a couple different ways you can go about looking at these. And what you decide to do is usually determined based on like what would make this the easiest thing to work with here. So when I look at a problem like A, I remember that this notation right here means the same thing as x to the third power and then taken to the fourth root. It also could be written as x to the 1/4 whole thing cubed. If I were to choose to look at it like this, these both mean the same. If I were to choose to look at it like the one that I have a purple box around, what would need to be my first step as I try to solve this? How would you undo something that is a fourth root? Yes, we would take it to the fourth power. That would make my root cancel out so that I'd be left with x cubed. But if you do it to one side, you got to do it to the other side. That's going to be huge, isn't it? That's going to be really hard for me to do in my head. So, what about if I think about this in an equivalent way, but written slightly differently? So if I look at this one, if I had x to the 1/4 power all cubed equals 125, this is the thing that I would have to get rid of first. How would you undo something that is to the third power? Cubed root, yes. If I do the cubed root, that will cancel out. And if you do it to one side, have to do it to the other side. So my cubed and cubed root would cancel. That would leave me x to the 1/4 power. What is the cubed root of 125? 5. It was much easier in this case to do this and make my number smaller before I deal with that other piece. Remember, to the 1/4 power, that is the same as the fourth root. What would I do to get rid of the fourth root? Not quadruple it, that's timesing it by 4. Take it to the power of 4. It does not matter which way you write this, it's the exact same idea. Well, 5 to the 4th power, I'm going to have to do a little bit of mental math with this. 625, absolutely, because it's 5 squared times 5 squared. So I get that x is 625. It's not that doing it the other way was wrong. It just got too difficult for me to do in my head. With part B, what do you notice about that equation that's different than part A? There's a variable on both sides. What do you think we need this equal to? 0. If you've got variables on more than one side, you have to get them to the same side. So I'm going to set this equal to 0 because of this variable right here. So I'm going to subtract 5y from both sides. So I have y to the power of 3 over 2 minus 5y equals 0. And now both of these terms have a y in them, correct? This y is to the first power. I'm going to factor out a y to the first power. Let's talk about what that would leave me with now. Yes, y to the power of 1/2 minus 5. This is fully factored and it's equal to 0. So what can I do with each of those factors to figure out the values for y that would make this true? Yes. So I have y equals 0 from this factor right here. I don't have to do anything to solve that for y. It's already alone. And then I have y to the 1/2 power minus 5 equals 0. I want to solve this for y now. What would my first step be to get the y alone? Yep, we're going to add 5 to both sides. So I have y to the 1/2 power equals 5. How would I get rid of a 1/2 power? Square it. So the squared and the 1/2 power cancel each other out. That leaves me with y equals what? 25. All right. On C, do I need this one to be equal to 0 or no? Yes, I do. So I'm going to set this equal to 0. That means I'm going to subtract x to the 1/2 power from both sides. So I have x to the 3/2 minus x to the 1/2 equals 0. What do they both have in common? X. X to the first power? They at least both have an x to the 1/2 power. So that's going to be what I bring out to the front. Did you have a question, Logan? Oh, got it. If I take an x to the 1/2 power out, what would I be left with? X minus 1. This is fully factored. What do I do with each of those factors now? Set them equal to 0. X to the 1/2 equals 0. X minus 1 equals 0. How do I get rid of that 1/2 power again? Square it. What do I get when I square 0, though? I get 0. So one of my solutions is x equals 0. What is the other solution? X equals 1. Awesome. Yes, sir.
So basically, if you have two variables, you're always end up with two solutions?
Often. I can't say always, because sometimes we'll have repeated roots, and so it would only come out to be, say, one solution or possibly no solutions. But yeah, if you've got the variable in there and we're going to have to factor one of them out, chances are you're going to have two solutions. Yep. Do you guys have any other questions for me about this concept? Yes, sir.
So how did we get x equals 1 you like try to like plug it back in, it wouldn't work at all.
Well, let's check it. That's a great opportunity for us to go back and check to see if it actually works. Do you guys agree that 0 would work for both?
Yeah.
Okay. So if I do 1 to the power of 3/2, what's 1 squared? What's 1 to the 3rd power? What do you think 1 to the 3/2 power is? 1. Because either side of it is a 1, so we're going to get a 1 from doing that. And then on the other side, to the 1/2 power, that's the square root. What is the square root of 1? 1. So in this case, it does work. With any numbers other than 1 or 0, this would not be true. Do you guys have any other questions for me about this? Okay. There's 2 more types of equations that we need to talk about. So we have equations with rational exponents. We're going to look at equations with radicals. Specifically square roots, except for part B here. A and C are square roots. B is a 5th power. We're going to have to watch out and check for extraneous solutions. All right, so on the first one, I have 2x minus 9 underneath my radical, and I have a 1/3 on the other side. Square it. So we're going to square both sides. On the left, my squared and square root cancel. So I just have 2x minus 9 equals, what'd you say? It is 1/9. Square your numerator, square your denominator. What can I do at this point if I don't really want to mess with a fraction? I can multiply everybody by 9. Can I do that if it doesn't have an equal sign? No, it's got to have an equal sign if you want to do that. All right, so I would have 18x minus 81 equals 1. Plus 81 on both sides. So I have 18x equals 82. And then? Divide both sides by 18. Can I reduce that at all?
41 over 9.
You said 41 over 9. I like it. Can it reduce any more than that? No. How do I know if that is my final answer or if it's extraneous? Yep. Let's substitute it back in and make sure that both sides are actually equal. So I'm going to do a check. So I have the square root of 2 times 41 over 9. Minus 9. This should come out to give me 1/3 if we've done it correctly. 2 times 41 over 9, what would that be? 82 over 9. So I have 82 over 9 minus 9. Well, 9 is the same as what over what? Not 9 over 9. 18 over 2. I want a common denominator of 9 here.
Over
81 over 9. I can rewrite this as 81 over 9. Because now I can subtract those. 82 minus 81. So I have 1/9 underneath my radical. And that is true. The square root of 1 is 1. The square root of 9 is 3. So that does check out. So far, so good? All right. Part B, we've kind of increased our difficulty a little bit here. It's set equal to 0. Do I want to leave it set equal to 0? Will that allow me to cancel my radical? No. So I'm going to move that minus 2. I'm going to add 2 to both sides so that I isolate my radical. 5th root of 2x squared plus 1 equals 2. How do I get rid of the 5th root? 5th power. Powers cancel roots. What is 2 to the 5th power? 32. A couple different things we could choose to do here. I think one is easier than the other. Subtract 1 from both sides. Absolutely, we can do that. So I get 2x squared equals 31. Divide both sides by 2. X squared equals 31 over 2. Square root both sides. X equals the square root of 31 over 2. Is there a denominator that is under a radical? Then what do we have to do to it? Not by negative. Yes, we're going to multiply top and bottom by the square root of 2 so that we can rationalize our denominator. So I have the square root of 31 over the square root of 2 currently. I need to multiply top and bottom by the square root of 2. What will that give me in my numerator then? The square root of 62 over the square root of 4, which is 2. Yep. Can the square root of 62 simplify at all? I know that 2 goes into it, right? That would leave me 2 and 31. What goes into 31? Nothing. Then it doesn't simplify. It's not divisible by a perfect square other than 1. Can I call this my final answer? Need to check it. What else did we forget? It happened right here. Plus or minus. Why? Because the square root. We took a square root of both sides, so we have to remember the plus or minus at that point. So I need to include that. Oops. All right, so I'm going to take this. We're going to substitute it back in because I need to know if both the positive and the negative work here or not. So I have the 5th root of 2. Let's do the positive one first. Square root of 62 over 2.
Can't you just do 2x and just substitute x in equal plus 1 equals 32? Like the second, you just do the second equation since it's the same thing.
Do the second one.
Yeah. Like you substituted in for the 2x squared plus 1 equals 32. But
Like
under that.
under
Instead
that,
of having
doing
to
it
go
right
over-
here?
Yeah.
The only thing that I would caution you about is if you're not going all the way back to the original one, sometimes you'll miss extraneous solutions. Because like over here on this one, we squared both sides. If we'd gotten 2 solutions, it would be very possible to get something that would give me a negative under here that I wouldn't see if I only substituted it in here.
Okay. So
Does that make
always do
sense?
the original one?
I would always, always, always go back to the original one. All right. I know my 2's are going to cancel here. And then oh wait, I can't do that yet. I got to square it first, right? Yeah. Exponents first. What am I looking at? 62 over 4. So I have the 5th root of 2 times 62 over 4 plus 1, and then minus 2 out here. 62 over 4. and then I multiply it by 2. You get 124 over 4, or I would reduce right here. Because now I have 62 divided by 2, and you know that that's what? 31.
Why is it 62 over 4?
Because you had to square the numerator and the denominator. The numerator was the square root of 62,
Okay.
but the denominator was the whole number 2. Good question. So I have the 5th root of 32. What is the 5th root of 32? 2. Checks out. If I have a negative under here, does that change this at all?
No,
No, why?
it's squared.
Because it's squared, so it's going to turn it into the positive. So positive or negative works here. So we can keep both answers. On C, I have x's on both sides, right? Normally we want to get our x's to the same side, but if I get my x's to the same side, can I get rid of my radical?
No.
No. Radical has to be isolated for me to get rid of it. So how do I get rid of that square root? Ooh, big sigh. Why a big sigh, Lizette?
It's located a lot of words. Like, it's easy, but it's a lot of words. Like, you can mess up and get it.
Yep. All right, left side is pretty easy. It just gets rid of my radical, right? What do we have to do on the right?
X squared
We do, but we've learned how to square binomials quickly, right? How is this going to square? X squared minus 10x plus 25. Square the first, square the last. Those will both be positive. Multiply your two terms together and double it. That's how we got that negative 10. So far, so good? What kind of equation are we looking at now? Quadratic. For a quadratic equation, what do I need this equal to? I'm going to add x to both sides. And I'm going to subtract 7 from both sides. So I have 0 equals x squared minus 9x plus 18. You can do the full area model if you want to, but because our leading coefficient is a 1, I can just do the x. What multiplies to my c, 18, but adds to my b term, negative 9. I heard negative 6 and negative 3. So I have 0 equals, yep. Oh, I'm so sorry.
Where is number 9?
Shh. Why did we get that negative 9 there? So right here, we had a negative 10x plus 1x. Negative 10 plus 1 would give me the negative 9. You're welcome. I'm sorry that I missed your hand up. What do I do next? 6 and 3. X equals 6, x equals 3. Are they both solutions? We have to check. Because we've got two completely different values, we are going to have to run two completely different checks here. So I have the square root. Are you guys okay if we start with 6?
Yeah.
So I have 7 minus 6 equals 6 minus 5.
Yeah.
Yep, because here I'd have the square root of 1. Here I'd have 1. That checks out. And then we still need to check 3. So I have the square root of 7 minus 3, which would be what? 4. So I have the square root of 4. Over here, I have x minus 5, so 3 minus 5. I get negative 2. Is that true?
No.
Nope. So what does that mean?
Whoa.
Wait.
Wait, you
Oh.
got in the square. Wait, never mind.
Wait. Negative 2 to
Hmm?
oh, never mind.
This is why we go back to that original equation. Because I keep my left side on the left, I keep my right side on the right. I'm not resolving it. I want to make sure that the left side simplifies to the same thing that the right side simplifies
So
to.
can't the square root of 4 be negative 2?
So because the square root was in my original problem, it is assumed to be the primary square root, the positive one only. If we have to take a square root of both sides, we have to consider both the positive and negative cases. But if it's already printed in the original problem, it's assumed to be the positive one. That's a great clarifying question. All right, so x equals 3 is extraneous, and x equals 6 is our only solution. How we doing? Good? All right, let's do a couple more with these radicals. And then we got one more type to talk about. Ooh. D looks horrible. You said square all of it? Absolutely. We're going to square this. We're going to square this. All right. Let's talk about the left side. This is a very complicated looking binomial. When I go to square a binomial, I square the first term. What's that going to do to this? Yep, drops my radical. So I have 7 minus 2x.
Would it be plus?
Nope, stays a minus. Good question, though. Because all it's going to do is cancel out my radical. I'm going to multiply these two middle terms together. Will that be a positive or a negative? If I multiply these two square roots on the left side together. It's going to be a negative. So this is going to be minus 2. And then I multiply these two together. Hold on. Let me write it down and then I'll explain. Do you guys remember just a moment ago on the previous one where we did, shoot, what was that? X minus 5. They don't just cancel. Tell me how to square this. This guy right here. X squared minus 10x plus 25, right? We're following this exact same pattern.
Oh, because you multiply 2 times the...
Yep. So I squared the first part. That was this. Now I'm getting my middle term. I'm getting this right here. Because of the minus in front, that's going to turn into a negative. I double the product of the two terms being multiplied together. Do you see the pattern? Okay. Yes. Then we're going to square the back part. What will happen back there? 5 plus x. This will be positive. And then after the equal sign, that's 4 plus 3x. That is really gross looking right there. Let's clean it up. I can look at this right here, and I can combine that with terms over here, right? 7 plus 5? 12. Minus x. And then I have minus 2, and that's being multiplied to this. I'm going to rewrite this under a single radical. I'm going to multiply those two together. I still have a radical to get rid of, right? So anything that is not under the radical, I want to go to the other side.
Plus 2. Plus x.
Close. I am going to minus the 12, and I am going to plus the x. I can't get rid of that 2 yet because it's being multiplied. So to get rid of that 2, after I subtract 12 and I add x, what will I have to do to get rid of that negative 2? I'll have to divide. So I have negative 2, and I have this guy. That is equal to negative 8 plus 4x. Then we... Yeah. Let me fix it. Hopefully this works. Yay!
You got a lot of time before it comes up.
Yes, sir.
I use the bathroom.
Yes, you may. Talk to me about getting rid of that negative 2. Divide it on both sides. That means I divide both terms by that negative 2.
Should I just go?
Yeah, you can just go. So I have 4 minus 2x. Square both sides again. Now I'm totally getting rid of all of my square roots, all of my radicals. So I have 7 minus 2x times 5 plus x is equal to, we have another binomial to square. 16. I'll have a 4x squared back here. What will my middle term be? Negative 16x. Because remember, you multiply your two terms and then you double it. Okay, I've got a quadratic equation. Talk to me about what to do. Yep, I want to distribute over on the left side. Double distribute. So I have 35 plus 7x minus 10x minus 2x squared. What'd you say? Combine the middle terms. Those two will combine together to give me a negative 3x. What'd you say, dear? We can. For a quadratic equation, what do I want to do before I look at any kind of GCFs? Get it equal to 0. So I'm going to subtract 35 from both sides. I'm going to add 3x to both sides. And I'm going to add 2x squared to both sides. Cancel, cancel, cancel. I get my 0 just like I wanted. Are you guys okay if I write the right side in decreasing order with the x squared at the beginning? Okay, so I would have 6x squared minus 13x minus 19. Okay. And then we need to factor this, right? I don't want to, but that's what we need to do. Will it factor, or do I have to use quadratic formula? Well, yeah, if you substitute into the discriminant, you're welcome, and you get a perfect square back, then it's factorable. But hold on, look at this. We need to find two numbers that multiply to this product, but add to this. What do you notice about these two numbers and that number right there? Yeah, so we already know how this is going to factor. It's going to be 6 and Negative 19, because that adds up to give me that negative 13 in the middle. Those numbers looked horrible, but hopefully it won't be so bad. I'm going to write this down using grouping. So I have 6x squared plus 6x minus 19x minus 19. I'm going to make my groups. Can you guys tell me what the factors are going to be? 6x. What can I take out of the second group? Negative 19. What will the other factor be? X plus 1. So what are our x's then? X is negative 1, or x is, yep, 19 over 6.
It's not negative 19, it's just regular 19.
Well, you would set it equal to 0.
Oh, yeah.
So you would add 19 to both sides. So it's going to be x is a positive 19 over 6. X is a negative 1.
Why didn't you multiply negative 19?
We could have. We could have, but I knew I needed a number that would give me that product, but that would add to this. And when I looked at those two numbers, I'm like, well, those two numbers already add up to that.
Oh, okay.
So I didn't need to multiply them together and go through all the factors, because I already knew I have my two factors, and it adds up to that middle term.
Okay.
Normally, I would have to. I was just trying to find something that made this problem a little bit easier, because this is not an easy one.
Do we have to check this monstrosity?
We do, because if I get a negative underneath the radical, is that okay? They are fair game. All right. Talk to me about this check. Which one do you guys want to check first?
Negative 1.
Negative 1. Okay. So I have 7 minus 2 times negative 1 minus the square root of 5 plus negative 1 is equal to the square root of 4 plus 3 times negative 1. What would I get right here? Yep, square root of 9. What would I get right here? Yep, so minus the square root of 4 equals, what would this one simplify to? Square root of 1. So I have 3 minus 2 equals 1. Is that true?
Yeah.
Cool. I like that answer then. We can keep that one. We still have to check 19 over 6. So I have I'm going to do this in a different color. Square root of 7 minus 2 times 19 over 6 minus the square root of 5 plus 19 over 6 is equal to my board fritzing out again. Come on, board. It's actually the Wi-Fi. Yep. When the Wi-Fi goes in and out, my board loses connection. Everything else in here is hardwired, but not that. Oh, come on. Come on. Stop. Let's try it again. All right, let's finish out this check and then we'll call it done for today. We'll finish out the last bit of it tomorrow. Equals the square root of 4 plus 3 times 19 over 6. All right, so I have 7 minus 19 over 3 minus the square root of, this would be 30 over 6 plus 19 over 6 is equal to 4 plus 19 over 2. 7. How would I write that with a denominator of 3? 21 over 3. So yeah, I get 2/3 underneath my radical here. Minus, I have 30 plus 19, so that'd be 49 over 6 is equal to 8 plus 19. Was that 27 over 2? So I have the square root of 2/3 minus 7 over the square root of 6. Honestly, at this point right here, if this was on my homework, I'd pull out my calculator and see if those two sides were equal. I know, right?
Cheating.
I'm not going to give you guys numbers this hard to check without a calculator. This one, by the way, before you leave the room, this one is not equal. So I would throw this one out as extraneous. We're going to do E, and then we're going to talk about quadratic type equations tomorrow. Your 2-5 homework is due Wednesday, which is the same day as the quiz for 2-4 and 2-5, but I want to spend tomorrow. Quadratic type equations are way easier than these radical ones. All right? 2-4 homework is due tonight by midnight. Also, I'm hoping you guys saw my announcement about the 2-2 and 2-3. I made those not due until Wednesday for correction so that you can choose to come to office hours if you want to.